Why did America stop using these free roof coolers? Long before air conditioners swallowed electricity and turned summer into a monthly bill, rooftops across America spun like silent machines from another age. Factories had them. Barns had them. Family homes trusted them. These spinning vents, often called whirlybirds, worked day and night without wires, motors, fuel, or computer chips. Then modern construction pushed them aside, even though independent testing showed they could slash attic temperatures by up to 37 degrees Fahrenheit and cut cooling costs by nearly 15%. So why did one of the simplest cooling systems ever built quietly disappear? The answer begins with a problem every house faces during summer. Sunlight pounds the roof all day, heating shingles until the attic turns into a giant oven. In many homes, attic temperatures climb above 150 degrees. That trapped heat slowly radiates downward into the rooms below. Air conditioners then fight an endless battle, running longer and harder just to keep indoor temperatures comfortable. Worse still, many homes route air conditioning ducts directly through that overheated attic space, meaning cooled air warms up before it even reaches the vents inside the house. Turbine ventilators were designed to break that cycle naturally. Their spinning heads harness wind power to pull hot air out of the attic while drawing cooler outside air inward through soffit vents beneath the roofline. The design looks simple, but the science behind it is surprisingly clever. The first force at work is pressure reduction. As wind passes across the curved metal vanes, air speeds up and pressure drops. That low pressure creates suction inside the turbine, actively pulling heat upward and out of the building. Unlike a static roof vent that simply waits for air to drift out, the turbine uses moving wind to accelerate the process. The second force is the stack effect. Even on calm days, warm air naturally rises because it is lighter than cool air. That rising heat escapes through the turbine opening, creating a steady upward draft. In other words, the system still works even when the spinning slows down. The third force is the Venturi effect. Air squeezed through the narrow gaps between the vanes speeds up even more, lowering pressure further and increasing airflow. Together, these three principles create continuous ventilation without consuming a single watt of electricity. That efficiency was not theoretical. Studies showed properly installed turbines could lower attic heat dramatically and reduce energy bills in hot climates. A standard 12-inch turbine could move hundreds of cubic feet of air every minute with only a light breeze. For homeowners in scorching regions, that translated into less strain on cooling systems and lower monthly costs. So if the technology worked, why did it vanish from modern neighborhoods? One reason was performance expectations. Older homes were built looser and breathed naturally. Modern homes are sealed tightly for efficiency, making ventilation systems more complicated. A single turbine often cannot handle the thermal load of a large modern attic unless several units are installed correctly. Another problem was durability. Cheap turbines develop squeaks, grinding bearings, and rattling noises after years of exposure to dust and moisture. Once homeowners started hearing metal whining through the ceiling at night, the reputation of the entire system suffered. Appearance also played a major role. Turbine ventilators stand tall above the roofline and spin visibly from the street. Developers and homeowners associations preferred cleaner-looking ridge vents hidden beneath shingles. Modern suburbs became obsessed with smooth, uniform rooflines, and the spinning silver ventilator no longer matched the image builders wanted to sell. Building regulations pushed the trend even further. Energy codes increasingly favored controlled mechanical ventilation systems that could guarantee exact airflow rates. Turbines depended on wind and outdoor temperatures, making their performance harder to measure consistently under strict regulations. Yet despite their decline, turbine ventilators still make sense in many situations today. In hot and windy climates, they remain one of the cheapest passive cooling systems available. They reduce trapped heat, help roofs last longer, and lower cooling costs without increasing electrical demand during brutal summer months. The real lesson is not that the old system failed. It is that modern construction priorities changed. Convenience replaced self-sufficiency. Hidden technology replaced visible engineering. But the humble rooftop turbine still proves an important point. Sometimes the smartest survival technology is not futuristic at all. Sometimes it is the forgotten machine already perfected generations ago. As energy prices climb and power grids strain under extreme heat, these forgotten rooftop spinners deserve another look. They cannot replace every modern cooling system, but they can reduce dependence on them. For preppers, homesteaders, and anyone chasing resilience, that matters. A device powered entirely by wind and rising heat offers something rare today: Genuine energy independence.